So today we're going to be learning about the sine and cosine of complementary angles, and then we're going to be using some trigonometry with Pythagorean theorem. So this is basically, I believe, the second to last lesson of this unit. So just a heads up, tomorrow we're going to be learning how to find the area of a triangle, but it's not like what you learned in elementary school. It's going to be a high school twist. Then on Thursday, you're going to be completing a review sheet. I'll have some office hours. That way, if you have any questions, you can email me, FaceTime me, whatever. And then on Friday, you're going to have your first test. You already had a quiz last Friday, and then you're going to have a test. Giving you a heads up, this is one of my favorite lessons because it's actually very straightforward. So, for instance, what we are going to be doing today is we're going to be working with complementary angles. And what we know about complementary angles is that they actually add up to 90 degrees. So what I'm going to do is I'm actually going to write a quick note saying complementary is 90 degrees. So for instance, if I wanted to use triangle PQR right here, I already have a 90 degree angle. That means between angle P and angle Q, they have to add up to 90. So that's what I know about that relationship, that they have to be adding up to 90 degrees. That's just a little fact that we're going to be using throughout this lesson. So what I'm going to do right now is, if you know how to do this right now, go ahead, do the sine of P, the sine of Q, and then cosine, tan, do it for all of them. But what I'm going to do is I'm just going to model how we do this. So I'm going to do sine of P, cosine of P, and tangent of P. So right now I'm going to go back to my picture. I'm going to do some erasing. And I'm going to look at P as my reference angle. I'm going to put a little red there. That way I know it's my reference angle. Remember, this is just SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. The first thing we do is we always label our hypotenuse, which is across from our right angle. So in this case, the 5 is my hypotenuse. All right. I draw an arrow from P because P is my reference, which means that 4 is my opposite. And then by process of elimination, 3 is my adjacent. So I know sine of P is my opposite over my hypotenuse, so it has to be 4 over 5. Okay. I mean, you should try these by yourself. What I would do right now is draw a triangle PQR with those labelings, and then try to find the sine, cosine, and tangent. What I'll do is I'll just go through them, but again, you should really be trying these by yourself. The cosine of P is my adjacent over my hypotenuse. So in this case, it's actually going to be 3 over 5. I'm just writing my fraction like that just for space reasons. And then tangent is opposite over adjacent. So tangent of P is 4 over 3. Okay. What I would like you to do right now is try to do the next row by yourself. Do sine of Q, cosine of Q, tangent of Q. But remember, that requires us to go back to our original image and change some things up. I'm going to do some erasing, because by changing our reference angle, our answers can actually end up changing. So right now, Q is my reference. My 5 is still my hypotenuse, but now 3 is no longer my adjacent, it's my opposite. And 4 is no longer my opposite, it's my adjacent. So whenever you're trying to find the cosine or the sine, or just using a different reference angle, your opposite and adjacent actually switch places. I think a student, I forget which one, but I think it was someone from 7th period who actually asked in one of the questions last week, what was it? Do you always have to find the sine and cosine and the tangent of each angle? And that's not true. You actually only need to find it once or twice, because the question will say, oh, what's the sine of Q, or what's the cosine of P? It's only going to ask you one trig function typically. So now we do our sine of Q, which is our opposite over our hypotenuse. So in this case, it is 3 over 5. I'm going to do these in blue, because 3 is our opposite and 5 is our hypotenuse. Cosine is adjacent over hypotenuse, so 4 is my adjacent, 5 is my hypotenuse. So that means cosine of Q is 4 over 5. Okay, 4 over 5. And then last but not least, tangent of Q is my opposite over my adjacent, so it's a 3 over 4. So one thing you should notice is that I am getting repeat answers in each row. I know that, I'm going to use my green marker, sine of Q is equal to cosine of P. I know that sine of P is equal to cosine of Q. And then there's really no relationship among tan, except that the numerator and the denominator flip. But that's about it. And those are the things that we're going to be looking at. We're basically saying that these two are equal, and then these two are equal. It's actually quite interesting, if you ask me. So here are some important facts that we're going to be looking at. The acute angles of a right triangle are complementary. They are complementary. They are complementary, which means that they add up to 90 degrees. Now in right triangle ABC, if C is right angle, then sine of A is equal to cosine of B, which we basically said before. So for example, what I'm just doing is I'm going to say that the sine, here's an example I'm coming up with, sine of 30 is equal to the cosine of 60. And I get that by doing 30 plus 60 equals 90. Or, this actually pops up as a Regents question, I think like once every year. It's basically just saying, and this actually pops up in the part 1, sine of theta is equal to cosine of 90 minus theta. That's another way of looking at it. You just want to find out which two angles will add up to 90 degrees. All right? Okay, so let's do some of our first examples. Whenever it says solve for x, all we're actually doing for these questions is setting up a very straightforward equation. Remember, we know that sine and cosine have to be equal to 90. So all we're doing for these questions, I'm going to give you a heads up, if I want to find out the value of x that makes sine of x equal to cosine of 63, I actually just set up a straightforward equation. My equation's going to be x plus 63 equals 90. So now that I have x plus 63 equals 90, I subtract 63 from both sides. And you can do this in your head. I'm assuming Jerry, Tommy, Chuckles, Hannah, I'm assuming all of you are doing this in your head at the moment, and then a bunch of other students are waiting for the other to use their calculator. 90 minus 63 is 27. So that's what x is equal to. So that's basically saying, you don't have to do this, but that's basically saying that the sine of 27 is equal to the cosine of 63. And if you actually want to see if that works, you can type that on your calculator and see that this will be equivalent to that. Number 2, I have the sine of 34, and I want to find out the value that makes it equal to the cos of x. So again, I just do angle plus angle equals 90. So I get 34 plus x equals 90. This is just a one-step equation. I take away 34 from both sides, and I get x is equal to 56. And that's your final answer. That's just saying that the sine of 34 is equal to the cosine of 56. So this right here is your check. That's your check. And you don't have to do a check ever, unless you're like really doubtful of your answer. That's what I tell the Algebra 1 students this year. Only check your answer if you need to check your answer. You should be at the point where you're trying these by yourself. I can zoom out if you would like, and you can write down these questions, you can write them down. You can write down this one, this one, this one. You should be trying all of these by yourself. But if you are still struggling, I can go through them. Watch the videos. Write down how we're doing them. So I have the sine of 45, and that's equal to the cosine of x. I just do angle plus angle, and I set it equal to 90. How do I get rid of a 45? I take away a 45. So I subtract 45, and I get x is equal to 45. And again, that's just saying the sine of 45 is equal to the cos of 45. I can type it in and boom, I'll get the same exact answer. Sorry I had to go get my charger. That's why there was a brief pause. But remember, you should be trying these questions now by yourself. We've done 3 examples. Now we go into like the level 2 territory. Okay, so we have the sine of 2x minus 1 and the cosine of 11. Again, we just do angle plus angle equals 90. So I have 2x minus 1 plus 11 equals 90. We combine our like terms, and we get 2x plus 10 equals 90. We're at the stage in our mathematical careers where Mr. O'Sullivan does not need to show every single step of the equation. I get rid of a plus 10 by subtracting 10. So 90 minus 10 is equal to 80. And then I divide both sides by 2. So I get x equals 40. Okay. If you're like, I don't really need to do any more of these problems, you can go on to the next part of the lesson, or you can make sure that you're checking your answers just by fast forwarding. So I have the sine of x plus 5 equals the cosine of 4x plus 10. I just do angle plus angle and set it equal to 90. So I get x plus 5 plus 4x plus 10 equals 90. I combine my like terms and I get 5x plus 15 equals 90. I get rid of a 15 by subtracting 15, and then I get 5x equals 75. And then I get x equals 15. Yeah, divide by a 5. And that's your final answer. Ooh, these are getting annoying. So I now have a sine of 1/2 x equals the cosine of x plus 24. One thing I would do, we know what 1/2 is equal to, so instead of writing it as 1/2, because we hate fractions. Well, I love fractions. Miss Kimmick loves fractions. All of you hate fractions. I'm just going to change this guy right here to a 0.5. So I have 0.5x plus x plus 24, and that's equal to 90. Remember, angle equals 90. 0.5 plus 01 is a 1.5x plus 24 equals 90. I now subtract 24 and I get 1.5x equals 66. Divide by a 1.5 and I get x equals 44. Boom, final answer. And then our last example on the front. I have sine of x minus 60 equals the cosine of x. Angle plus angle equals 90. So I get x minus 60 plus x equals 90. Combine those like terms, I get 2x minus 60 equals 90. Add 60 to both sides, I get 2x equals 150. Divide by 2, and I get x equals 75. So again, that's just saying that the sine of 15 is equal to the cosine of 75. So again, we just did 1, 2, 3, 4, 5, 6, 7 problems. You should be able to do these questions rather quickly. You know how to solve an equation. All right, let's go on to the next part of this lesson. Okay, so now we're going to be able to use trigonometry and the Pythagorean theorem to find missing side lengths. It's also going to allow us to find the exact values of trigonometric functions without using the calculator. So here's how we approach these questions. I'm not going to lie, these are my favorite questions. And here's why. It's a lot of work. So, step 1, we draw a triangle using our given information. So we're going to be using our given information. It's not a proof. There is no given midpoint. It's just givens. Use the Pythagorean theorem to find our missing side. So a squared plus b squared equals c squared. And then use the triangle to solve. So again, this all relies on our knowledge of SOHCAHTOA. SOHCAHTOA. Good. So in right triangle, whatever, sine of theta is equal to 1 over 2. So what I'm going to do right here, it says find the exact value of cosine of theta and tangent of theta. I'm going to draw a right triangle. That's when you would all yell at me and say, Mister, you don't know how to draw. So I know that sine of theta is equal to 1 over 2. And we know sine of theta is opposite over hypotenuse. So one thing I do when I do these questions, and I'm pretty sure Miss Kimmick does the exact same thing, is we actually label in our fraction our opposite and our hypotenuse. So, opposite, hypotenuse, and adjacent. We're now going to label that with our information. We know our opposite's 1, so we're going to put a 1 here. We know our hypotenuse is 2, so we're going to put a 2 here. Thing is, I don't know what my adjacent is, so I gotta solve for it. So I'm going to put an x there. Again, step 2 before said, let's double check. Step 2 said use the Pythagorean theorem to find the missing side. I do 1 squared plus x squared equals 2 squared. 1 squared is 1 plus x squared equals 4. I get rid of that 1 by subtracting, so I get x squared equals 3. Take the square root of both sides, and then I get x equals radical 3. What I'm going to do is I'm going to erase that x. I'm going to erase the x. Why isn't my eraser working? 1 second. I'm going to erase my x and put a radical 3 this time. I'm going to put a radical 3. Okay. So it says that we want to find the cosine of theta and the tangent of theta. We know cosine of theta is our adjacent over our hypotenuse. So we want to do cosine of theta equals our adjacent of radical 3 over our hypotenuse of 2. That's your final answer for cosine of theta. All right. I'm going to zoom in a little. It says now do tangent of theta. So tangent, I'll do in red this time, is equal to your opposite over your adjacent. If we look at our picture, our opposite is a 1, and our adjacent is a radical 3. Remember, step 3 said use the triangle to solve. Remember to rationalize the denominator if necessary. We are going to rationalize this, so let's practice rationalizing. I have that radical 3 downstairs. I care, so I get rid of it by multiplying by radical 3 over radical 3. 1 times anything is just itself, so I get radical 3. Radical 3 times radical 3 is radical 9. What makes 9? 3. Boom, you just found tangent of theta. That is your final answer. Cosine of theta is equal to the square root of 3 over 2, and tangent of theta is equal to radical 3 over 3. What I would recommend is try to do the next example by yourself. It's a little more challenging, but it's quite doable. So we endeavor into example 2. In our right triangle, an acute angle theta, The sine of theta is equal to 7 over 9. We want to find tangent of theta in simplest radical form. So for this question, we don't want cos, we just want tan. The first step, and the first step only, is to draw your right triangle. So we're going to draw our right triangle. You know what, that doesn't look like a right triangle. This is when you guys are going to be like, what the heck is he doing? So I'm going to redraw it. Yeah, that's the best it'll be. So I put my theta here. You could put your theta here, it doesn't matter. I just like to be consistent. It's called, been doing this since 10th grade of high school, so stuck in my ways. Sine of theta, we know, is 7 over 9. I know that 7 is my opposite. And I know that 9 is my hypotenuse. So one thing I should do is I should label my hypotenuse, my opposite, and my adjacent. Remember, the hypotenuse is always across from your right angle, opposite is across from your theta, and adjacent is last but not least. I'm going to label it in blue. I have a 7, and I have a 9. Thing is, I don't know what this is, so we have to solve. So I get 7 squared plus x squared equals 9 squared. 49 plus x squared equals 81. Subtract a 49 and I get x squared equals 32. Thing is, we need to be able to get this in simplest radical form. So take the square root, I get x equals. If you don't know how to simplify this, you can do your prime factorization, or if I taught you the trick with your perfect squares, you can do that. I'm going to do the prime factorization way because that's the way most of you are familiar with. 2 and 16, 2 and 8, and 2 and 4, and 2 and 2. So I have 1, 2, 2, 2, 3, 2, 4, 2, 5, 2. So I have a radical. 2 times 2 times 2 times 2 times 2. Circle your doubles. I got a 1, and I got a 2. What's 2 times 2? 4. Bring it on the outside. So I get 4 radical 2 as my missing side length. All right, take a breather right now. See how I found out what my missing side length was. Because now what I need to do is I need to figure out what tangent of theta is. So tangent of theta, I'm going to just zoom in on my triangle. Tangent of theta is opposite over adjacent. If I look, my opposite is 7, and my adjacent is 4 radical 2. Here's the issue. We don't like that radical, so we have to rationalize. I multiply my numerator by a radical 2 and my denominator by a radical 2. This simplifies to 7 radical 2 over 4 radical 4. Because 4 times 1 is 4, and radical 2 times radical 2 is radical 4. This then becomes even simpler. I get 7 radical 2 over 4 times 2. Because this becomes a 2. What's 4 times 2? 8. That's your final answer. 7 radical 2 over 8 is equal to tangent of theta. So this is all you do for the lesson. You basically draw the triangle, label it with your sine or cosine or tangent, whichever one they give you. Use Pythag theorem to find your missing side, and then use the triangle to solve. Rationalize those denominators if necessary. If you don't rationalize it, I won't take off 1,000 points. I might take off half a point. because typically you don't have to rationalize on the regions, like they typically give you the nice numbers in geometry for some reason. It's when you get to Algebra 2 with Miss Daniels, and if you take a college level math class, where you need to make sure those radicals never exist. Remember, if you have any questions, please email myself or Miss Kimmick. You do have a test on Friday. This definitely will be tested on there. And don't forget to post your daily question and to start working your independent practice that is due Friday. If you have any questions, please reach out. Have a great day.